Wednesdays for Water, an initiative of the W4W Foundation, a think tank built as a citizens collective. We welcome you to another session. We are really inching towards 100 sessions, to be honest, with Fridays and Mondays coming together to support the Wednesdays for Water. Wednesdays for Water is a water conversation series towards understanding better the nuances of water conservation and management. The objective is to engage with water experts, grassroots practitioners, policymakers, and youth to learn their thoughts and ideas about the complex intertwined issues associated with water and the possible solutions which they are really working towards. We have expanded, as I mentioned, Friday Waters and Monday Monsoon with Women for Water. Besides organizing water workshops, water walk and talks, seminars, special courses, and conference panels to continue the water conversation. You may like to visit our website w4w.in for more details. Today we are going to discuss climate change and the IPCC report and the current state of affairs, particularly focusing on India and maybe around and globally as well. Importantly, how water is perceived, studied, conveyed across discipline sectors, regions, nation states. And we are really privileged to have our speakers today to discuss, and they are Dr. Aditi Mukherji, Professor Subimal Ghosh, and Professor Vimal Mishra. All the speakers today are going to talk about their contribution to the IPCC report and giving us some layperson understanding of how things work and what is climate change and what we should be concerned and doing about. Before the speakers take us into the details of IPCC, let me introduce briefly what is exactly IPCC just in few words. The IPCC Alliance, the Intergovernmental Panel on Climate Change, is the United Nations body for assessing the science related to climate change. It provides regular assessment of the scientific basis of climate change, its impacts, which are risks and options for adaptation and mitigation. It was created in 1988 by the World Meteorological Organization and the United Nations Environment Programme. The objective is to provide governments and society at all levels with scientific information that they can use to develop climate policy. And our speakers are going to talk more about it actually. There are three working groups in the IPCC. The group 1 deals with the physical science, and the group 2 with the climate change impacts, adaptation and vulnerability, and the group 3 with the mitigation of climate change. It has also task force, but I think I will leave it to our speakers to talk more about this, where they talk about international collaborations and what these things are. I'm going to put the detail of IPCC website in the chat box later. So let me turn now to speakers now to throw light on what they have worked on, how do they see climate change, and what we can do as a society, as a community. So our first speaker today is my senior from University of Cambridge, Dr. Aditi Mukherji. She is a principal researcher at International Water Management Institute. Earlier, she led the water and air theme at the International Center for Integrated Mountain Development, which is IWMI, in Nepal. Aditi was a coordinating lead author of the water chapter in the working group 2 of the IPCC, published in February 22, and is a member of the co-writing team of the IPCC's AR6 synthesis report. So these words, I think Aditi will help us understand better. And I think the recent report is also published now, so you may correct us on that as well. Her areas of specialization are groundwater governance, energy, irrigation nexus, climate change adaptation, community management of water resources. And I can go on with her list of publications and her achievements in her life, but I think we keep it in the chat box for all of you. And let me invite Aditi, and after her speech, I will introduce our other speakers today. So Aditi, I will start with a very layperson question to you, so that you let us know. So what were you working on, and what were the key findings that you can share with us, where we can really start scratching our head what we can do as a society? Over to you, Aditi, and thanks again, all of you.
Yeah, thanks so much, Mansee, and for your kind introduction. It is an absolute honor to speak at Wednesdays for Water, something I have been following quite diligently on Twitter so far. So it's great to get this opportunity. To answer your question, what was I doing in IPCC? I was helping write this chapter on water, So water chapter is written in two working group. Working group one, which is more around physical basis of climate change, more of the natural side of the story. So there is a water chapter there. And the water chapter that I led was in the other working group called working group 2, which is more about human society, impacts of climate change on human societies and on ecosystems, as well as how ecosystems and humans are adapting to climate change. So it is around vulnerability and adaptation. So just to give a bit of a flavor of what exactly this work is about, I just would have I have a small slide deck. This is this is a slide deck from our water chapter, which has contributions from over 60, 70 authors, of which 12 were chosen by the IPCC Bureau as coordinating lead authors and lead authors, and the rest we had almost 50 plus contributing authors from around the world. Many of them were early career researchers. So it was a large team, and we managed to synthesize and assess 4,000 plus pieces of literature and articles, mostly journal articles, to kind of come to a current state of where we are in terms of impacts of climate change on water and how our society is adapting to those changes. What are those adaptations and whether those adaptations are working or not. Mansee, feel free to interrupt and ask me if something is too technical or not understandable. I will try and be as use a simple language. So what is it? So it's a huge report. But I can distill it into 5 major things. My 5 major conclusion from our water chapter is that climate crisis is here and now. Climate crisis is also water crisis. And why we say that is because climate change has led to changes in all components of the water cycle, be it precipitation, evapotranspiration, be it precipitation in the form of rainfall or snowfall, melting of glaciers. So each of those components of the water cycle has been affected. So that's number one. Number two is because because water is used in every sector, there is almost nothing that doesn't use water. I mean, water is the basis of life. So those impacts in the water cycle has transferred to almost every sector of the economy and the society. And the most impacted happens to be also the sector which uses the most water, that's agriculture. Agriculture, as we know, is a very weather exposed sector. So a lot of the impacts of water changes due to climate change has happened to agriculture. That brings me to our third point, which is majority of the people, particularly in the global south, and particularly people like farmers, fishermen, and everybody who is in primary sector, more weather exposed sectors, they actually experience climate change through water. They necessarily, I mean, of course, in the urban areas, we also experience climate change through extreme heat. But when it comes to farmers, farmers are the first and foremost to experience climate change through delayed monsoon, through higher variability in rainfall, etc., also through floods and droughts. So water is how a major share of people are experiencing climate change. The fourth point is also, while water is what people are experiencing changes in water, quite interestingly, water is also what's helping them to adapt. Again, I'm mostly talking of more of those climate exposed sectors, but also urban sector, for example. A lot of the adaptations are around water. So adaptations include, for example, irrigation, water management, rainwater harvesting. So water plays an important role in adaptation. And as someone has said, the provenance is not clear who said this remarkable quote, but they said it said that if mitigation is about carbon, then adaptation is about water, and that's absolutely correct. And finally, to bring to the final element, and I will not cover all of these elements today, I will be brief, but the final element is that what we now know is climate change is here and now. We are already living in a 1.1 degree, when now it's almost 1.2 degree world. And what's very clear is that we have to emit less, stop emitting greenhouse gases. We have to reduce CO2 emissions and greenhouse gas emissions immediately. And that's called mitigation in simple words, but many of these mitigation also involves water. So, so while the solution to climate change or mitigation needs to incorporate water. So that's kind of my 4 or 5 major outlines that I wanted to talk about. A bit more detail is that we find that hundreds of millions of people are experiencing changing precipitation. This is something that comes very clearly from Working Group 1 report, and we quantify it in Working Group 2, where we are seeing that almost 500,000,000 people are experiencing wetter conditions than they were doing since 1950s. All these comparisons are from 1950s. We are also seeing that heavy precipitation has increased over many areas. So, for example, 709 million people approximately globally are seeing more heavy precipitation than they did in the 1950s. So that's something quite unequivocal all around. And human-induced climate change is likely the main driver. I think Subimal, Professor Ghosh will talk about it more, but one of the advances in AR6 is a lot of clear attribution. How many of these changes can be attributed to this increased CO2 concentration in the atmosphere? The attribution studies have become much more stronger in this cycle. Okay. What we are also seeing is that dry spells have increased in some areas and decreased in others. So we are so this is kind of one of those paradoxes, more rain, but also more dry spells. So we are seeing global population, almost 700 million people are seeing longer dry spells compared to 1950s. And some of these are some of the droughts that we encountered recently. The 2017 drought across all of Tanzania, Ethiopia, Kenya, all of Eastern Africa. These droughts contributed to extreme food insecurity approaching near famine condition. And the attribution studies show that these drought conditions made twice as likely by human-caused climate change. Similarly, warming also magnifies drought by evaporation. A very interesting case is that of 2017 drought in the northern plains of USA. Again, a breadbasket, etc. But here, the chances of drought increased due to increased evapotranspiration, and there was a clear climate change angle. Similarly, while in flooding, our current evidence, there isn't a lot of global evidence that says that floods have changed in magnitude or intensity due to global warming, due to climate change, but a lot of it is also an issue of data, etc. But there is some evidence that some floods, like spring floods, especially in higher latitudes in cryospheric zones, has become more intense. But overall, most of our findings related to floods are in the future, and is showing that flooding is projected to change with ongoing warming. So basically, the frequency of floods is going to increase at higher levels of global warming. This is a low emission, more like equivalent to 1.5 degree world. And so the higher the warming, the more is the model agreement. And these are all the areas where we are going to see increased flood frequency. And you can see the South Asia is one of those. One of the things with floods, less so with drought, but one of the things with floods is the damages from floods are also a lot of it about human intervention, right? If there was no one living in those floodplains, there would not have been any of those damages that we see. So the flood damages also has a very clear quote unquote natural hazard dimension, but also very clear human intervention dimension that makes doing these flood projections a little harder than otherwise. Okay. Then if we look at Asia overall, and of course South Asia, these are some of the major risks that the report identifies. Heat stress. We have a very good example this year. We saw in March how our heat waves, the longest heat wave in whatever 120 years, we were told that led to unprecedented damage to wheat crop, and the human costs are of course on top of that. And then there was a crisis in energy sector and all of that. Water scarcity, I think in the context of South Asia, we understand this is already a reality. Part of it is climate change, but a large part of our water security is also simply our poor policies. So while we talk about climate change, let's not forget that policies also have a big role to play, and climate change is just making those inefficiencies even worse. Food security is, I think, a major emerging issue, and it's now looking pretty certain that neither will we be able to keep ourselves within 1.5 degree that the Paris Agreement urges us to, nor will we be able to meet many of these SDGs like zero hunger by 2030. So standing now in 2022 and just 8 years down the line, it looks pretty grim, and climate change will have a big role to play in the fact that our food security goals will not be met. Flood risk is another one that has been identified, and also especially around sea level rise and the coastal cities. Uh, I'll just skip this. Uh, we have to remember that climate impacts and risks are uneven and mediated by non-climatic factors, as I was saying. Not everybody will face these climate risks equally. So the heat waves does not affect those of us who have the luxury of working from home or working under air conditions, while heat waves had a profound impact on a day laborer or a person who has to be out in the field. So that's pretty obvious, right? So, and these are mediated by non-climatic factors, the existing vulnerability, the current poverty level, the current livelihoods, and all kind of structural barriers. In the context of India, that would be also caste, that would be also historical deprivations that come all the way from colonial times, but also a lot of it is around the current entitlements, etc. So caste is an important dynamics around which we see that these vulnerabilities actually manifest themselves in the context of India, caste, gender, and others dimensions. Many of us are very interested in what will happen to Himalayas. This is another assessment, not really IPCC, but HIMAP, which was done by ECMOD. I was involved in it. And what is showing is that even if the world, by any chance, by a miracle, managed to limit themselves within 1.5 degree, it will still be too hot for the Hindu Kush Himalayas because of something called elevation dependent warming. And almost in a 1.5 degree world, almost the region is projected to lose 1/3 of the glaciers. In a 2-degree world, 50% loss of ice volume. That's a huge, not so that's a huge one. I mean, you're completely changing how the region looks, and also not only the water but also the aesthetic values of these resources. In our IPCC assessment, we actually did an assessment looking at some of these, and many of these regions of the high mountains have indigenous people. So we looked at how these impact the indigenous people, who are often very marginalized, again, due to historical and political factors. So this is some work that we did in Ladakh long ago, but it really shows that, I mean, it's this very dry area. These are these snow-capped mountains and glaciers far away. They have a system of bringing in water to irrigate these fields. And when we work here, communities tell us about the delayed, early melting of glaciers, etc. And they say, what can we do? The reality is that they can do very little. The glaciers are not melting because of their impact. They hardly have any carbon footprint. So it's basically the high emitting countries that has caused this global warming, and the sufferers are these frontline people, like these people in this Ladakh village, who are having to relocate even. So at the end of it, climate change is not only about physics, but it's equally about justice and equity issues. I think this is more or less I wanted to talk about. The other part is just last 2 slides, is water is also central to adaptation. This is a slide from our water chapter, which is kind of, we listed all the major ways in which people are adapting. Some of them, many of them are in agriculture, improved cultivars, changing cropping pattern, on-farm irrigation, water and soil moisture conservation, etc. And we find that many of these are actually in response to floods and droughts, water-related hazards. And when it comes to future, what we are finding is that these very same adaptation methods may not remain very effective in the future. Right now, at the current level of global warming, even if suppose we are able to change our cropping pattern or crop system, they remain effective now, but at a higher level of global warming, they do not remain effective, and they actually remain, the residual risks are very high, which says that even adaptation has a limit. You can only adapt to a certain level of warming, and much of our studies are showing is that that limit is reached between 1.5 to 2 degrees. You cannot simply adapt to 3 to 4 degrees. I mean, take this example of our 50-degree centigrade days in March, and no wheat crop is able to endure that kind of temperature. So this is something to keep in mind, that we cannot endlessly keep adapting. At the end of it, the solution really is to reduce emissions as far as quickly as possible. And this is where we had this concept of climate resilient development. Is also true many countries, including ours, there are a lot of development deficits. Here, the idea is to stop emitting greenhouse gases, but still work hard at achieving sustainable development. With this, development needs to be low carbon, including in countries like ours. So I'll stop there and just say that this is one of those. I thought the working group too concluded that the scientific evidence is unequivocal. Climate change is a threat to human well-being and health of the planet. Any further delay in concerted global action will miss the brief, rapidly closing window to secure a livable future. Thank you, and I'll stop there.
Yeah. Thank you, Aditi. Some alarming stuff for us, and also to think a lot about us. But what is the important learning for me from your very little talk? Sorry, we have very short time for each speakers, but
no worries.
The idea is to really connect with people. You show still a sign of optimism, saying that if crisis is, and more talking is about carbon, but our mitigation, then adaptation is about water. So that is a very good connect for people like us who are really looking at how and what we can do at individual and institutional level. So we will take questions towards the end. So thank you so much, Aditi, for opening up the discussion for all of us to take it further. May I now move to Professor Subimal Ghosh to really give some more insights on the extreme conditions. But before that, let me just quickly give a short introduction. Professor Subimal Ghosh is the convener of an interdisciplinary program in climate studies and a professor in the Department of Civil Engineering at IIT-Bombay. His research interests include hydroclimatology, regional climate modeling, understanding the Indian monsoon and its variability, mesoscale hydrological modeling, water resource systems, urban climate, and still stimulating land surface feedback to climate. He has several publications, as most of the experts we are usually inviting here, but importantly, his publications include Nature Climate Change, Nature Communication, Science Advances, Geophysical Research, Letters, Water Resources and Research, etc. He's recipient of several awards, but I'm going to put all the details later in the chat box. But let me again invite Professor Ghosh with a very simple question as a student of water. Because most of us, we do relate that climate crisis is to large extent water crisis as well. Subimal, how do you really see this, and also how would you like us to understand it in extreme weather conditions? Because we are seeing flood and drought occurring simultaneously every year and to the extremes. So with these lines, I invite you again and thank you for taking time for us, and over to you, Subimal.
Thanks a lot, Mansee. Thanks for the invitation. I'm really honored and humbled, to be present here and to share some of our work which we did. And yes, this is mostly, in IPCC, I was involved in chapter 11 of assessment groups, report 6, working group 1, which works on climate science of extremes. And we are involved in understanding different extremes, attributing it to human-induced climate change, and what are the changes which we have seen, and what are the future possible changes. So these are some of the areas which we tried to cover. But more importantly, what I'd like to mention is that, which I have been mentioning over last few years, that, for this country like India, everyone, if you go to a farmer or if you go to anyone, everyone says that climate is changing, we're aware of this. So it's not like Western countries where you have to really continuously fight with the climate deniers and say that, no, look, climate is changing, this is what science is saying. Here, most of the people are actually believing science, and they're saying, yes, even if there is an extreme, they say it is because of climate change, even if it is not because of climate change. So that's the condition. So the thing is that, but they're looking for solution. They're looking for adaptive tools, or how can they improve their adaptive capacity. That's here the challenge is this one: how to improve our adaptive capacity so that we can save our population for the next 10 years or 20 years, and that's the key challenge. So we have to improve our climate services, and we have to improve our forecast. We have to improve. We have to really improve different tools, because our country is developing a lot in terms of technology development. The idea here is that how can you bring those technologies for increasing the climate resilience of different sectors with sector specific tools. That's the challenge. So without spending much of time on that, maybe I'll just quickly tell what exactly we have done in IPCC, and then we'll just show that some of the simple tools, how it can help the people. Yeah, so when you're talking about observed extremes and attribution, this is a very known story, so I'm not again repeating it. It's that climate extremes are increasing. Yes, it's increasing, and majority of the extremes, increased extremes or intensification of extremes, are because of human induced climate change. So it is sort of, science says this, and in this country we do not have a problem because we have very few climate deniers. So most of the people believe that it is because of climate change. And now if you look into the the observed changes, of course temperature is one of the variable which is sort of very well simulated, easy to simulate by climate model. So we have a very strong evidence that heat waves have increased, and it can be attributed to human induced climate change or greenhouse gas emissions. This is essentially the global map. You can see it's some form of map where South Asia is somewhere here, and you can see that the heat waves have increased, and these 3 dots means there is a high confidence that human contribution has led to increase of heat waves in the South Asian region. Now, if you are considering the extreme precipitation, of course, trend shows that about the South Asian region, the extreme precipitation has increased, but we have limited agreement to say that human contribution has resulted into change of this extreme precipitation. There is a reason behind it, why there is a limited agreement. This is because precipitation is a very difficult variable to simulate. Water or precipitation related variables are difficult. I'll just give an example. So let's say if you're cooking popcorn, when you are preparing a popcorn, that entire handi is getting heated up. Where you are actually preparing, entire bowl is getting heated up. The temperature is high, but you do not know which corn will pop up first. So precipitation is like instability, or from which region maximum corn will pop up. So precipitation is like more about instability, and which region will become more unstable, that results into more extreme precipitation and so on. So that's why precipitation is very difficult to really attribute an increase in local increased extreme precipitation to a human induced climate change. For the drought, of course, we have seen a lot of occurrences of drought over the recent period. But when it's about literature review, there was a lot of disagreements, low agreements in the type of changes. And so the team members, the lead authors group who are involved in the sections for drought, they said that there is low agreement in the type of changes. But one of the very important thing which we have to understand here is that of course, Indian monsoon has seen a lot of periodic kind of behavior, and because of that, mean looks very similar, but extremes have increased. So essentially, the low to medium rainfall has reduced, that results into more soil moisture drought and so on. Probably Vimal will be talking about them. So that's one of the things we have to understand. Again, this has low confidence simply because this is related to water. Anything related to water is a challenging task. Now, there is another thing which has come to IPCC report, which talks about compound extremes, when 2 of the extremes are occurring together. Let's say sea level rise and storm surge, they are happening together. Or precipitation in combination with strong winds in terms of tropical cyclone, or droughts and heat waves happening together, or floods and sea level rise. So these are some of the things which results into compound extremes. I'll give an example. Let's say if you're talking about, I am in Mumbai. So let's say if you're talking about Mumbai, when heavy rainfall occurs at the same time when there is a high tide, what happens? The rainwater cannot go out, that results into waterlogging, severe waterlogging. So it is often said that if heavy rainfall period coincides with the heavy rainfall hours coincides with the high tide condition, that results into extreme flooding over Mumbai. Now, consider a condition when the sea level is rising, or because of the storm surge, we have a very high level of level of the boundary condition. Then what will happen is that the flood water cannot go out, that results into compound extremes. So this is another important thing which we have to understand, so which are increasing. Now, I'll quickly move to, considering there's a time constraint. So what I'll do, I'll quickly move to some of the possible solutions, which are very simple, but this needs to be developed. So, one of them is urban flood forecasting. How can you, I'm talking about urban flood forecasting. There is a reason behind it. I'll tell that. And then flood risk forecasting. How can you really develop flood forecasting considering the vulnerability and exposure kind of component? I'll tell you why are they really, really very important. And then flood evacuation. So these three are series of things which are essentially needed to save people from flood. So urban flood forecasting, this thing came in 2015. We know that in Chennai there was a severe flood. Immediately after that, the principal scientific advisor, then Dr. Chidambaram, visited IIT-Bombay, and we had a lot of discussion related to urban flooding. And we realized that there is no end-to-end real-time flood forecasting system for this entire country for any of the cities. So Dr. Chidambaram has requested me to lead a group of around 30 scientists to develop a real-time urban flood forecasting system, which should be end-to-end. And we picked up the Chennai city. So this is what we started with, and we developed it for Chennai in a record time of 1.5 years. Thanks to my colleagues, they have done a tremendous job. And there are 8 institutions involved. These institutions are ISC Bangalore, then IMD, then National Center for Coastal Research, then INCOIS, then National Center for Medium Range Weather Forecast, then IIT Madras, Anna University, and so on. So, the urban flood forecasting specifically for a coastal city is a complicated system. Why? Because urban flood itself is a complex thing. Then urban rainfall is sort of intensified because urban region have some impact. Urbanization has some feedback to rainfall. There are oceans, there is a storm surge. So tide and storm surge impact you have to consider. There are buildings, roads, and everything in the urban region. So that makes it very complex. And if you are considering, there are upstream watershed from where the water comes, and there are reservoirs. So reservoir operation is also playing a major role. We know in Chennai flood, reservoir operation was actually playing a major role. So there are a lot of things you have to collect a lot of data, you have to model them, and you have to come up with the forecasting system. So that is a bit of very challenging task. So yeah. So rather than going into the details, I'll just tell you what are the components which we have considered. So we have considered, the rainfall. We have considered National Center for Medium Range Weather Forecast model, and then we have further performed a quantile regression to understand, given a forecast, what is the higher quantile of rainfall values. And if there is a high rainfall values, then we have considered the radar data and did an outcasting with radar data assimilation, and this has been considered. Then coastal condition, with the help of INCOIS, we have developed tide and bathymetry, tide and surge forecast. Then hydrologic modeling, upstream hydrologic modeling was done by IIT Madras. There are a lot of water sensors which were installed. Then hydrologic modeling is done, and upstream hydrologic forecasting is being done. And then the flood model were done by one of my colleagues, Professor Karmakar. And then we have to collect a lot of data. That was one of the major challenging tasks, but we could finally do. And we could try to get an inundation forecast for 6 to 72 hours. And word-wise maps we could generate. We could even generate a locality-wise map or building-wise map. Of course, in a small region, for same buildings, we'll get a similar kind of water level. That we cannot help. But with the 3D visualization, at least we can say that these are the regions where it needs an evacuation. And it starts with first, if you look at the portal, it looks like this. Let's say 31st October 2017. It will give for next 3 days: 1st November, 2nd November, 3rd November. And given a forecast, what is the 80th percentile of flood map, 85, 90, 95, and 99. And if you click on it and zoom on it, then you will, like a Google map, you will be able to see what will be the flood condition under 98th percentile, 95th, or 99. So this was developed, and the entire technology was transferred to NCCR, and Ministry of Earth Science is using it as sea flows, and they have exactly followed the same algorithm for developing the I flows for Mumbai. Now, second one is forecasting flood risk over a large region, and this is being done for Kerala. So after Kerala 2018 flood, we thought of doing something. I'll tell you the reason. So normally the conventional approach of flood forecasting is that you have a weather model, you do a bias correction, then do a hydrologic modeling, do some hydraulic modeling, and then visualize the inundation in a two-dimensional thing. But what we thought is that over a large region, if you have to do this kind of hydraulic modeling, it normally takes a lot of time. Hydrologic modeling will be easy, but hydraulic modeling will be difficult. So then, and if you're really considering each and everything properly, so then what is needed is that, what we thought is that, can we come up with a simpler approach? So what we did, a very simple, like in climate scale, we consider the risk concept, we have put it in weather scale. So what we did is that we have taken the weather model and observed data. We have done a very simple joint and conditional distribution. We have said that given a forecast, let's say if I am forecasting, IMD is forecasting for tomorrow, given that forecast from the past, we are trying to find out the distribution of rainfall and find out the probability of extreme rainfall, let's say rainfall greater than 100 mm or something, and we consider it as a hazard. Then we have considered socio-economic condition and topographic condition to compute the vulnerability, and land use land cover to compute the exposure. So we have combined all three components to generate the real-time forecast of flood risk. We have filed a patent, and one of our work is Sabarmati Party, one of my students did this. So this is the Kerala region 2018 flood, and you can see this is the rainfall, and you can very clearly see that high rainfall regions do not really result into high flood, simply because what Aditi was also mentioning, that vulnerability actually plays a major role. The more vulnerable regions will see more loss and damage, and that's what is happening. So just flood forecasting will not help if you cannot include the vulnerability information. So again, with some of our collaborators, we could develop the vulnerability map, and we could do. The second problem was that, if you are considering the forecast, GFS, NCEP GFS forecast we are trying to use, and then we found that it is unable to produce the rainfall over the correct locations, even at lead day 3. From lead day 2, it started doing it. So there was a problem in the forecast. So what we did, we developed our conditional distribution and then merged it with multiplied it with vulnerability and exposure. And then what we have found, for most of the regions, we could actually identify the high loss regions, even from lead day 10 or lead day 7. The problem was only this district. You can see this district we could not do. And when we looked into it, we have found that this district has saw a lot of losses because of the landslides, and our model could not consider landslide. So if you have to further improve it, you have to consider vulnerability to landslides, considering the slope stability, and you have to do a very serious, of course, slope stability analysis with geotechnical engineers, and then you can further update it. The third one, it came from the practitioner or from one of the government officials. So one of our student, who is a district, I think district collector over a district in Odisha, and during the COVID time, when there was the forecast for Amphan, so she was kind of bit confused. I mean, not really understanding that how to start the evacuation, because if she has to start the evacuation, what will happen is that there will be a lot of people in a shelter, and that will, if there is a spread of infection, then it will be uncontrolled, because during the flood time, waterlogged situation, if there is a lot of COVID patient, I mean, she cannot take care of, I mean, she cannot do anything, but at the same time, you have to evacuate. So this is what we did. One of our young colleague from IIT-Gandhinagar, Professor Udit Bhatia, who did a fantastic work in terms of developing some kind of a COVID model with complex network, and we used it with the flood evacuation model. The idea here is that we developed a multi-objective optimization model where we are increasing the number of evacuations, at the same time reducing the number of infections after 7 days stay in the shelter. And when we did that, we applied it for the Jagat Singhpur district, which is a flood-prone and cyclone-prone region. And what we have found is that this model is able to pick up those regions which are highly vulnerable. So essentially, we use the concept of vulnerability here, and it could actually evacuate most of the people who are very, very vulnerable to flood. But it is not really touching those people who are not really much vulnerable. And at the same time, it is really minimizing. It is distributing the evacuees in such a way so that you will get quite a less number of infections compared to the condition if you don't really consider this kind of optimization model. So we shared with them, and they were actually very happy. So that sort of tools, which are not very difficult to develop, but this kind of tools can really help us and can really help us to adapt to the increasing extremes. Thank you for your attention. Thanks.
Wow, great, Subimal. At least you really took us through how one of the components, in this case flood, can be really taken to the ground, right, to the point of evacuation, from forecasting and modeling, and then really working on the ground with officials as well as community to take actions. What was more, I will say, comforting was that you were also talking in terms of preparation, forecasting, and evacuation as part of adaptation, which is, I think, more stressed by scientists all over, where one part is you prepare for climate change, but at the same time, you have to continue adapting to it, and forecasting itself becomes part of adaptation. So that's good to learn. I will keep it short from my end because I want to get Professor Vimal Mishra on board to really have a conversation later with all of us together. Thanks, Subimal. So let me now invite Professor Vimal Mishra to have the last speech of the day. You have heard both of them, Aditi and Subimal. So before you speak, let me just give a brief introduction of you, and I will put the later part of introduction in the chat box. So Professor Vimal Mishra is a professor at IIT-Gandhinagar in civil engineering. We have had a couple of meetings in Ahmedabad for some water discussions and all. He is also with the Ministry of Earth Sciences Waha Mihi Research Fellow. His research focuses on understanding the impacts of climate variability and climate change on various aspects related to humans and society, such as water resources, energy, infrastructure, and food security. I'm also aware that you are really working on a lot of things related to, water epidemics also around your colleagues. He integrates observed and remotely sensed data sets with large-scale hydrologic modeling to answer important questions related to human-climate interactions. So, Vimal, thank you once again to join us. It's really good to see you online. I would prefer to meet you more offline in the city. But you heard both Aditi and Subimal how they really decoded the thick volumes of IPCC, and Aditi gave the findings in broad words, and Subimal really tried to tell us how that is decoded into doing the ground activities. So we like to hear from you to wrap it up from your end, and over to you, Vimal, and really good to see you again here.
Yeah, thank you, Mansee, for the kind introduction, though a lot of information is obsolete old, so I have to change my probably website to put the newer information. Anyways, I'm a professor at IIT-Gandhinagar. Thank you, Dr. Aditi and Professor Subimal. I mean, you have covered almost everything. But I was in another workshop and recently finished a talk just a few minutes back. And I will share a few slides just for discussion point of view about without taking a lot of time. So let me share my slides. Mansee, can you please?
Yes, go ahead.
So what I presented there was, water sustainability challenges under warming climate in India. And, so, I mean, without going all these slides, what I can tell is important, like how we are going to adopt the changes that we are witnessing because of climate change or otherwise, because a lot of pressure is on our water resources, even if we don't consider climate change. Say, for instance, how groundwater storage is changing to sort of meet the food demands. And how urbanization is happening, how water demands are increasing. So of course climate change is playing very significant role to sort of in the water resources. So so what I discussed was water cycle and climate change, what IPCC 6 talks about, sustainable development goals, and then I quickly discussed two things: food and water security in Indian context, and also irrigation demands and groundwater depletion. And so looking like, and how 2019 looking like with respect to 1951 and 1980. This we all know that. But what is important, we all know the first bullet. The second, I think, and third are very important in Indian context. What Professor Subimal was saying, like this how monsoon will change, or why it is difficult to sort of get the precipitation projections right. So when we think about adaptation, and if we have not very reliable projections of rainfall, because we get most of the water or from the summer monsoon rainfall, then it becomes quite challenging what the decision makers or policy makers should do in that condition. So why it is complicated, IPCC also sort of touched upon that, and it is because of anthropogenic aerosols. If you look at the Indo-Gangetic plain, we have quite significant presence of aerosols. Also land use change, and also water withdrawal for irrigation, and how we are changing our land surface through all these factors. I mean, greenhouse gas emissions definitely is a very significant contributor, but anthropogenic aerosols and irrigation, land use change, these also complicate that how entire monsoon system will change in the future. So there is quite a bit of uncertainty. Now, water, climate change, food security, these are very, very essential when we talk about sustainable development goals, and they are very, very tightly coupled or interlinked all together, because climate action 13, SDG 13, if we don't do that, we are going to face already facing significant changes in the water cycle that puts pressure on water availability, water sustainability, that is linked with the food security. So goal 2, goal 6, and goal 13 are very well linked, and you can say that water is the center or of basically, or climate change in water are the center or the key goals that we want to sort of address if we want to do well in terms of food security. Okay, so what are the questions related to climate change adaptation in context of water resources in India? So we need to sort of understand how climate and human interventions will affect the changes and variability in the summer monsoon. So what will happen if we keep increasing aerosols, irrigation, land use, land change, and along with the greenhouse gases emissions? And then also, if you look at the past record or observations, there has been a quite significant change in rainfall intensities over India. So that I can discuss, and how those rainfall characteristics will affect our surface and groundwater storage, surface and groundwater resources, and how will water use in agriculture in the future change, and what would be its impacts on overall water sustainability. And here the groundwater becomes sort of center point of entire climate change adaptation, because we don't want to fail our agriculture, given that the significant population. Also, not everybody can afford very high food prices in our country. We did some work. I mean, so monsoon remains the key driver, because one of the major crop growing season that produces quite significant amount of cereals is the Kharif season, and that overlaps very well with the summer monsoon season. But there is always a variability. So any monsoon season, you will see a lot of areas getting flooded, and also a lot of areas will face droughts. And when where drought happens, basically you will see that problems in terms of groundwater pumping, in terms of crop failures. Like this year, what happened in UP and other places in October, there is a flood. Rice crop completely about to be harvested got flooded, and farmers sort of have no choice what to do, because they will possibly, I was reading somewhere, they will possibly, rather than selling rice, they will be buying rice in the near future for their survival. So we looked at in one of the papers published back in 2020 that how the droughts or the area under droughts have increased or changed in India. And you can see in the top panel that major droughts, some of the major droughts during the monsoon season, be it 2002, 65, 72, 87. And one thing is interesting, whenever drought occurs during the monsoon season, there is a very high temperature also. So these two together can basically impact the food production. We also looked at that. We have made tremendous progress in terms of food production, but again, our food production during the Kharif crop is very well coupled with how the monsoon will do. And we looked at what controls drought and, other things, how those are linked with El Nino or the largest scale climate variability. We identified or reconstructed all the major droughts. But what was interesting to learn that despite increase in rainfall, the risk of drought may not go very well away, because the nature and characteristic of drought will change. So droughts can come like, rather than seasonal, very large, long lasting droughts, we may see very hot and dry extremes, which are not so long. Let's say 20 days, very hot and dry period, it did not rain. And those could put a lot of challenges in the crop production during the Kharif season. And classic case, if you study the 2015 drought during the monsoon season over Indo-Gangetic Plain or in the Gangetic Plain, you can see that was published in GRL a few years back. What we sort of linked with that work, that monsoon drought affects the groundwater storage during the not only, but also the upcoming winter season that you can see here. These are based on the GRACE observation. So drought during the monsoon puts a lot of pressure on groundwater. That is one thing we can remember and learn. Now, after 70s, there has been tremendous increase in the area irrigated by tube wells. You can see that area irrigated by tube wells has increased quite tremendously. On the other hand, other surface water-based irrigation like canals have lot. We don't find that kind of increase. So we have now developed capacity over the years to pump groundwater across the country, and more so over the Gangetic Plain. And that has caused depletion in groundwater that is basically evident by both observational bells as well as the satellite-based observations. Okay. But what is more important and challenging for us is how the rainfall in the past has changed. Regardless of most of the projections say that there will be increased rainfall in the future, but if you look the observations, it's a contrasting. So observations suggest that there has been significant decline over the one of the most populated region in the Gangetic Plain, and more remarkably so, the low intensity rainfall has declined across the country. High intensity rainfall has increased in the Western India and some other parts, but this is more significant because we have also established in this paper that low intensity rainfall is very, very important for groundwater recharge. So if you have less low intensity rainfall, your groundwater recharge gets affected, because we cannot manage the floods occurring for a few days and then longer dry periods during the monsoon season. So the rainfall characteristics have also changed. So we looked at this in the Ganga basin, that what are the major controls. So we can see temperature has gone up, rainfall has gone down. We also sort of put a model called HO8 that simulates irrigation, groundwater pumping from deeper aquifers, shallow aquifers. So there are some comparison model versus GRACE. You can just say that model is doing reasonable job capturing the interannual variability. But we figured out that around 225 kilometer cube water lost in roughly 18 or so years in the Ganga basin only. And the major contribution was the pumping for irrigation, and that increases basically during the drought years. You can see what happens during drought years, that recharge goes down, abstraction goes up. So roughly 15 to 20% increase in pumping and about 20 to 30% decrease in recharge. And you can imagine that if that happens under climate change, when temperatures are warmer, this abstraction could even be intensified. And that can really put a lot of pressure on our groundwater systems. So what we are trying right now to understand that whether the climate change future projections suggesting increase in rainfall can help us recover the lost groundwater that in the northern India. So these are again some results showing the observations. There has been significant loss in the groundwater. So in the northern India, we have lost almost about 400 kilometer cube water in this entire region, including Punjab. And so over the last few years, these are the comparison model versus GRACE-based observations. But we learn one thing, that there is a lot of uncertainty that you can see regardless of projections you take. because there is an increase in rainfall. So, okay, there will be a recovery, roughly half of what we have lost. So we have lost about 400 kilometer cube. It can help us to recover 200 kilometer if the projections really happen. Because we are not sure, given that observations are suggesting more droughts, declining rainfall, projections are suggesting increase, but there are wider uncertainties, we can say, and we have to sort of consider these, that we are not sure what is going to happen in the future in context of groundwater. But one thing we can, which is sort of clear, that even with very positive outlook based on the rainfall changes, it may be very difficult to recover what we have already done with our groundwater systems in India or northern India. This is again from IPCC, future water cycle changes. This will continue. There are contrasting projections in monsoon precipitation. What is more important thing we can remember is that the characteristics of rainfall have changed drastically in the past based on observations, like decline in low intensity rainfall, increase in high intensity rainfall, more floods. So this entire distribution of water, how much water will be available for how many days, that also puts a lot of pressure. And also the nature of monsoon, like in October, flooding, nobody would imagine this is the time to harvest crop. Now farmers are rather than harvesting, they are trying to see their entire, losses and witness losses. That is truly remarkable. And if this continue to happen, I don't know what would be the sort of how we can adopt these kind of changes. I mean, during the monsoon we expect floods, but when monsoon is gone in October, mid-October, flooding happening in the agricultural regions is very strange. Again, this is the last slide. I mean, water remains the center of climate adaptation, climate change. You talk about energy, hydropower, climate mitigation, that again linked with the water. You could talk about food security, food prices, again linked with the water. Disasters, most of them tropical cyclone, floods, droughts, are linked with the water. So we need to certainly do more in terms of how much do we know in terms of impacts of climate change on water. But what we can do, like Professor Subimal talked about climate services, how we can adopt early warning systems, real-time monitoring, how we can help people of our country to manage these, adverse impacts that are caused by climate change. Thank you very much.
Thank you, Vimal. And it's really such a rounded up discussion today, with Aditi starting with the overall and Subimal giving it, a detail how it is converted into practice on ground, and you really bringing up into one aspect where you talk about groundwater, because still it is not really discussed how they are interlinked. So thank you so much, Vimal, for giving this insight now. And we had some good data to munch for all of us, but because at Wednesdays for Water, we try to really bring in our participants to give their suggestions and questions to all of you. So maybe I do have a lot of questions, but then I invite people to really engage with our speakers today. So please put up your questions in the chat box, or you can just unmute yourself and speak. So over to you, to all the participants. Or I will start with some question if people are really thinking how to engage. Okay, so let me just give a question from my end, because I do see from the scale of operations, from writing the report, researching, and then making it really accessible to people. I have a very naive question as a citizen. We all are feeling the climate change. We are feeling drought and flood. What is most ironic is that water everywhere, and we still have water problem. That's a common question which, as a common citizen, we realize and we do understand. So one part is that we work on adaptation, but another part is prevention or behavioral change. So maybe I start with Aditi. Where do you see that people can be really informed in a way what they can do with this climate change information? Everybody knows now there is climate change. what we can do as a citizen, as a community.
Yeah, I mean, it depends on which citizens, which communities you're talking about. I think adaptation is easier if you are already, you already have certain minimum level of entitlement. Adaptation for you and I is much easier than it is an adaptation for a small and
Yes.
marginal farmers. I think when your livelihood is already so precarious as our farmers' livelihood is,
Farmers.
a major investment needs to goes into really improving their livelihood. And we know with the agriculture overall, with the low cost of low price of these food grain, farmers are hardly making any profit at the end of the day. And we also have this compulsion about keeping the food prices low. As Professor Vimal rightly points out, there are still a large share of the people who cannot even afford the food prices at this current price. So I feel that there is this whole thing about how do we make agriculture more viable, more economically viable. Unfortunately, it isn't. And all the farmers who are farming are doing that because they don't really have any other alternative. So that I think is a major challenge, how to make agriculture more viable, and then climate change is adding to that challenge. Already there is an agrarian distress that's happening that's beyond climate change. So sorry, I don't really have a solution, but
yeah, but you made a very interesting point even during your presentation, where you said that the vulnerability is adding on to the climate change, because beyond these natural disasters, we also have these social cultural layers which add on to it, like the well-off we are much easier to adapt in terms of we can afford everything, whereas farmers are at a crossroad, because we are also seeing the interest in farming going down in the country. We are seeing these kind of distresses are really increasing. They are demotivating them, and at the same time we are seeing younger generation not so much really inclined to take this kind of risks in their endeavors, and that makes it more complicated with climate change. But if we focus then now more on taking one component, so I'm coming to you, Subimal, with the talking about flood, and you did mention how you were really trying to engage with the community through government and policymakers to do the forecasting, evacuation, mapping, and so on and so forth. Do you really get an opportunity to see where people are also talking about, can we also start talking about preventing few things apart from forecasting and all kind of evacuations and other things? Is there any effort from the government to really even, we cannot stop climate change now, but some kind of SDG 12 approach, responsible consumption and production? Subimal, you have to unmute yourself.
Yeah, so that's an interesting question, and that needs a lot of research to find out what are the different adaptive technologies or adaptive methods which have been used by farmers by the government, sorry, to reduce the impacts of flooding. One of the thing is that majority of the rivers are very polluted, and let's say if you're considering the urban river, because we live in Mumbai, let's talk about Mumbai.
Yeah.
So in Mumbai, the Mithi River, which is one of the major reason behind flooding, and in Mithi River, we still, it's not only government. I mean, the entire population who are suffering from flood, they keep on dumping, all the waste into the Mithi River during the non-monsoon period. And in the monsoon period, immediately, government has to, I mean, they try. I mean, I know BMC has really tried over the last few years in dredging and, taking out all the waste so that there will be a proper flow of water, and then there will be not much of flooding and so on. So we cannot really just blame, government. We have to also blame ourselves as well, because we should not, keep on dumping waste to the river when we know that because of that, because of dumping waste, we'll be suffering from flood. The second thing is that, there are a lot of flood banks or river banks where there are a lot of illegal construction which are going on, probably from somewhere through some corruptions. Some of the builders are getting permissions, but the problem here is that the population is actually buying those apartments, knowing that they are on the river bank, and if there is a flood, they will be the most vulnerable people. The flood, they will be most affected people, but still they are buying. So the problem here is it unawareness, or is it something, this is futuristic, बाद में देखा जाएगा, जो होगा बाद में देखा जाएगा? I mean, that kind of attitude also needs to be changed. I mean, So that's also another thing which I'd like to highlight. Um, I mean, related to the agriculture also, I'd like to mention one of our recent experience. We visited in one of the place which is all of us know about Mohabalash. It's a very nice place. 6,000 mm rain it receives over the western side of Satara. But in Satara also there are few rain shadow areas where there is no weather station. So essentially those are the regions which receives 250 to 300 mm rainfall. But if you consider Satara district as a whole, it's a water surplus district, and so if you consider the vulnerability to drought, it's not, almost not there, and I mean nobody really cares about them. And what happens, there are few villages where I mean they're actually suffering, and there are a lot of people who have moved to to different urban regions like Mumbai, Pune, and making the region more and more vulnerable, because that is mostly women and aged people are living over this region. The other problem is that over this region, there are few people who suddenly thought that if in 1 year, if they get a good rainfall, then they can grow grapes, and through grape farming, they will get they can make a lot of profit. And with that hope, they have tried to do, and they have lost all their savings and everything. They are actually in terrible condition. There is another farmer, what he did, he just I mean, there was only one borewell. He did 50 borewells with all his savings and lost everything, because if water is not there in one borewell, he may not get anything in the other wells. So this is the way actually they have lost their savings, they have lost everything. So some of these things because of unawareness, but some of these things even they know that sometimes maybe grapes, sugarcane may not be the correct crop for that region, but hoping that rainfall this year will get better rainfall. So, and if there is a profit, it's a lottery kind of thing. People love to play lottery. So probably
I
I
think
mean
it's a
that kind of what I say, I mean attitude needs I mean it needs a change. I mean,
we are in
I'll
prisoner's
not just
dilemma
blame,
trap.
yeah,
We are
yeah.
in the
I'll not
trap.
just, yeah, I'll not only blame government. Actually, government,
Absolutely.
population, all are responsible, and probably we scientists are also responsible, because we are also only thinking of publishing papers and etc. and stopping there. We never want to communicate to the common people, these villagers. We have to communicate to them. We have to understand their
Very
problem, and we
well
have
put.
to talk to them. So that part was entirely missing in our academic culture, and one of the major problem is that nobody gets any kind of incentive or any kind of awards for really talking to the people who really need science. So that is also another problem in
Absolutely.
the academic world. So there are
You
a lot of
actually
issues.
nailed it. You nailed it. Because that's the very purpose why we started Wednesdays for Water. We really wanted to decode the hard science and bring the policy experts and scientists and speak to us, speak to citizens. I mean, and speak in a very simple language. I think the climate science or climate education has yet not reached Indian education or Indian societies and coffee table discussions, unless and until it becomes a coffee table discussion, we are not bringing a change, to be honest. I mean, that is very much required. And that was the very purpose when I was conceptualizing Wednesdays for Water. And now we see people are receiving it in good way. But then we have to really do a lot on climate education. I mean, I was here in Stockholm for this Nobel Prize Teacher Summit. And all the discussion was, how do we really make climate education so simple that everybody talks about climate? The way we talk about soccer, the way we talk about cricket in the country, the way we talk about Bollywood, water needs to be talked about, climate needs to be talked about in a layperson language. And that's very much required. I think there has to be some very robust education on climate to everyone, so that people start understanding to take informed choices. So we are all trapped in prisoner's dilemma situation. Why should I, or let others
Exactly.
do, or let me try? So I will move to Vimal to really talk about how do we bring climate science or education, because one of the major concerns which we see and which is kind of a dilemma and confuses all of us, as Subimal was also saying, let me try, that what is this phenomena that we have drought in monsoon? I mean, it's unimaginable that, how do we convey this to people, and how do we convey that our behavior towards groundwater is really not good. We are the largest groundwater consumers in the world.
Yeah, I really don't know the answers, unfortunately. I would
Of
be
course,
very
you all
honest,
don't
but I
know.
can say one thing, that droughts during monsoon is a well-known phenomena. If you look maybe last 1,000 years, or we have looked famines during the British era, and we reconstructed some of the droughts that occurred in 1700, 1800, and 1900. Droughts have been occurring during the monsoon season. This is not new. Okay. What is new is that now the impact droughts are having is much, much more than that was used to earlier. Earlier, mostly there is a food insecurity, there is a famine. Of course, there is a lot of deaths, mortality because of famine. So I cannot say that was not impactful. But right now the investment has gone up, and the cost of everything has gone up so tremendously that even cost of groundwater is not so cheap, because farmers, to talk to farmers, especially those use diesel pumps, or even electricity costs are not cheap in some of these states, because it is not subsidized. So I mean, droughts have been happening. They will happen in future. The unfortunate part of Indian agriculture is that there is no plan B. And
Yes.
I come from I mean, a farming background. I can say my father was a teacher, but we also have a land where we grow crops in UP. So I know and I understand that. Now, assuming that farmers have less knowledge of something is also again not very, very true. As a scientist, as a professor, I can see my father knows all the aspects, that wow, there are risks involved. But again, I said there is no plan B. Now think about, we grow potato. October is the month when potato sowing happens. There is huge investment. Think about the cost of urea and phosphate and potash, everything. The fertilizer cost has gone up. And this year was drought year, so most of the time farmers might have invested in irrigation to prepare the land for the sowing of potato crop. Again, they pay a lot of seed. Seed is very expensive, potato seed. And when you get this flooding, this is all gone. So what the problem is that it is very difficult to protect the losses in agriculture. And agriculture insurance is one thing, but the reality, unfortunately, is that many times farmers are unable to get the appropriate, benefits of getting insured. That is not very, very straightforward. It is complicated, I would say. So, I mean, what we can do, I mean, we can provide information to farmers, like we can say there will be a drought, but then what are the options? Should they not so there is a gamble, as probably Subimal said, there is a lottery, and that lottery has been going on. Like I can say in our region, in UP, farmers grow massively potato, and once in 5 years they get profit. This is the average. But still every year farmers will grow potato because they don't know which that once in 5 year will be. Maybe then this year. And this is a lot of investment. But once 1 year in 5 year will cover the entire losses, and they sort of get something. Now, Indian agriculture is also based on lot of, I would say based on borrowing money. We do agriculture without borrowing because my father was a teacher. We have sufficient revenue coming and we can invest in input cost. But other farmers who don't have a continuous source of income, and those who don't have enough land, they will end up borrowing from cold store or someone else. And when they lose money, this is very, very, disappointing, unfortunately. Now, if you go and give the gyan to farmers that you don't pump groundwater, come on. This sounds very good looking at the depletion and other things, but farmers, they have bigger problems to solve. And that bigger problem is that they must generate sufficient revenue from what they are doing, because that is the only livelihood they have. We can say
And food for us.
don't pump groundwater, don't grow rice, don't grow maize. But unfortunately, that hasn't been working because farmers are not protected. So until unless we consider agriculture as a service, like in service, we get summer salary, we get salary, whether it is tropical cyclone or anything. This is unfortunately not the case for farmers. They have to play the game, and sometimes they win, and most of the time they may lose. But that is the only way they have, right? So if you give, let's say, a job, peon job to farmer who is having like 5-acre land, he would happily go for that peon job because that is secured. Even if salary may not be very high, 10 to 15,000, 20,000 rupees, because that is secured income every month. So the situation really is very, very tricky, and that has been the case why we have not been able to make or cover a lot of ground when it comes about water sustainability in India, because until unless we change agriculture, until unless we change how farmers feel what is their priorities, and when the water becomes center point of their priority, which will only happen when they have some sort of security of getting their livelihood, and then only we can save water. And I will stop here. I may have sounded like very negative, but unfortunately, I've seen agriculture from my childhood, and I know how
And this is practical.
yeah, I'm a professor, but I come with we have land, we
The
grow.
heart of farmer.
Exactly. So this year we did not put rice, and my father was very happy that we did not put rice. It was drought in UP, but we must have put potato, or we must have started preparation of potato. So it's a timing uncertainty. So I would say agriculture in India has a lot more uncertainty than climate projections, because it has social, it has economic aspects, it has climate aspect, all uncertainty put together, it becomes much larger than what is coming from the climate change.
Yeah, very well put. And I think you also made a very important remark that we cannot really give gyan to people who are actually suffering more from it. And when we talk about farmers, farmers are growing food for us.
Yeah, I would just add, like, we can provide solutions. We should go to farmers with solution. When you have solution to solve a problem, and in solution, you must ensure that there is a profitability. Okay.
Absolutely.
And then only it will work. If we just say on the moral ground that you don't do this because we will face a very problem of groundwater crisis, unfortunately, that doesn't work. It's hard.
Yeah. But a very good point also made that unless agriculture is made a service, and I see Aditi is also writing that we need better risk management for agriculture, especially social safety, and which is almost endorsing what you guys have been talking about. Let me take a question from Gopakumar sir from Kerala, and Aditi, you may actually resonate and also respond to it. How climate change adaptation can be made a component of development policies of the government, especially to meet the Paris Agreement targets? We are almost 8 years just away from it now.
Very briefly, I'm conscious of time, is that I think that, I worked in Bhutan, and one of the nicest thing I see that whatever policies they have this lens of whether it increases their gross domestic happiness. So they actually scan their policies from a perspective of gross domestic happiness. And I think in India, given that we are at the forefront of climate impact, we are just so vulnerable given our location in the tropics, given our own history, given our kind of societal challenges we have. I feel that it's high time that all our policies are scanned from a lens of is it helping us becoming more resilient to climate change? Is it helping us adapt better? So our development, on the one hand, our development policies are often making us even more vulnerable. Look at the spate of construction of highways in the mountains, or the hydropower. On the one hand, hydropower is supposed to give us more energy security, but on the other hand, it is estimating deforestation, exactly. So I think this is high time that we start scanning our policies from a perspective of, is this development also going to make us more climate resilient? And that would lead to a whole lot of changes, hopefully, but it's easier said than done. I am not a policymaker, I'm a researcher, so it's very easy for me to say this needs to be done. But really, I mean, we have to see development as not as a separate silo from adaptation. Development has to be in a way that helps us adapt and become more resilient. Otherwise, what's the point of development if it's making us even more vulnerable?
Yes, in fact, taking us to more miserable conditions than ever, I think. So, I mean, somewhere we have to really bring human well-being at the core of everything. Unless and until we do that, economy is going to push the development harder, and it is not ensuring neither ecology and not even basic facilities for even those who are vulnerable. So I think that's a long discussion to be taken up, but we stick to climate change and also try to stick to time. Often we go 75 minutes. So I really thank all three of you, Aditi, Subimal, and Vimal, to really take out time and enlighten us with this simple conversation, how we can look at climate change, what are the dilemmas, how the report can be really decoded into simple decisions or actions or suggestions, for example, forecasting and evacuation, and how these interesting phenomena can be understood, which are age-old phenomena like drought in monsoon, or they go simultaneous, hand in hand. Especially looking at the vulnerable community, very well put again, that the climate distress is also disparity, because it also brings out that some people, section of the society, are more affected than others because others have more resources. And this is where adaptation is not only optimism, but it is only the way out. And very well put also the point that if carbon is about climate change, then water is also at the center of adaptation. So with these words, let me also thank again all the participants who have been listening to us live. We do notice that there are more people on live than here, registered here. So thank you all of them. And thanks to all the participants and my team member to really make Wednesdays for Water and other sessions meaningful. We have Monday Munching with Women for Water as well as Friday Waters. So coming Friday, we have an interesting discussion, which is a water book session this Friday. And we talk about the struggle for Narmada and oral history of Narmada Bachao Andolan by none other than its very well-known author Nandini Ojha. So we meet at 5 p.m. Friday. And the next Wednesday, we have relevance of step wells to as of today, as you know, Indian context landscape has many of these water structures, which are beautifully made. So that's on October 19th at 5 p.m. again. And Monday, we continue meeting our women water leaders across the country. We have so far met nearly 40 of them, and we are still having many of them to be met on Mondays. So we are not sharing the name of the Monday woman because it comes very spontaneous to us on that day before. So thanks again to all of you, and really I'm having a best masterclass I can imagine in my life on water from all the speakers around the world. And particularly today, thanks again to Aditi, Vimal, and Subimal. Please take care of yourself. We see each other soon and see all of you in the coming Wednesdays and many more Wednesdays to come. So we are at least going until December, and we know that. Thank you so much.